Alright guys, Mr. B here. In this video we're going to be going over the practice problems in the Chapter 2, Section 2 notes on mixtures. So here we go. Number 1, a physical blend of two or more substances is a... Alright, so this is directly from the notes. This is known as a mixture. Okay, so a mixture is a physical blend of two or more substances. Number 2, mixtures may be identified as blank or blank. Again, this is directly from the notes, but there are two ways that we identify mixtures. They are either heterogeneous or they are homogeneous. And if you don't remember what each one means, the best way to remember it is hetero and homo, what those two things mean, right? Like heterosexual, homosexual. Hetero means different or multiple or opposite, and homo means the same. So mixtures that are heterogeneous have different parts in them or opposite parts or, things like that. And homogeneous mixtures have things that all look the same. Okay? Easiest way to remember it. Number 3, homogeneous mixtures are also known as blank and have uniform properties. Again, this one is directly from the notes. These are also known as solutions. Okay? So another word for a homogeneous mixture is a solution. All right. Number 4, explain the term phase as it relates to homogeneous and heterogeneous mixtures. Okay, so first we'll define what the word phase means and then how it pertains to homogeneous and heterogeneous. So, a phase, and let's actually make our font here a bit smaller. Let's maybe make it like size 20. There you go. Okay, so phase is a portion of a mixture that all looks the same and has the same properties. Okay, so we'll say a phase is a portion of a mixture that is uniform. Okay, uniform means it looks the same and has identical properties. Okay. Maybe we shouldn't put the identical properties part in there. Let's just say it's a phase. A phase is a portion of a mixture that is uniform, and yeah, no, it's fine. We'll say it has identical properties. That's fine, I guess. Okay. So for homogeneous mixtures, they have one phase. Okay. Homogeneous mixture it looks the same throughout the whole thing. So one phase. Heterogeneous mixtures, on the other hand, mixtures have two or more phases. At minimum, they have two, because a heterogeneous mixture is a mixture with parts in it, different parts you can see. So at minimum, there has to be at least two phases, because you can see the two different parts. That's what makes it heterogeneous. But it can certainly have more phases. It just depends on how many, right? But at minimum, it's got two. All right. Number 5, how are a substance and a solution similar, and how are they different? All right, so this is a good question. Just make sure we change our font and color here. So substances and solutions. So remember that a solution is just another name for a homogeneous mixture. Okay. So let's think about similarities. Okay, so substances are things that have a uniform composition. That means that they look the same throughout the whole thing, which is very similar to a homogeneous mixture. They also are uniform. But a substance also has a definite composition, which means that no matter where in the world you find it, it's always going to be made out of the exact same stuff, no matter what. Homogeneous mixtures, although they look the same, they're not always made the same. Okay, so here's a prime example. Think of a bottle of Gatorade. A bottle of Gatorade, let's even pick a flavor. Let's say like fruit punch, okay, the red one. One bottle of fruit punch, let's say you go buy it from like a Holiday gas station in, I don't know, Mayer. And then you go buy another bottle of fruit punch Gatorade from the grocery store in Watertown. Those two might look the same. So they're both uniform in terms of how they look. But their composition is going to be slightly different. Okay, when I say that, I mean this. One of those bottles might just have a little bit more sugar in it than the other one. Or one of them just might have a little bit more salt in it than the other one, right? Or maybe a little bit more coloring. Now, by looking at it with your eye, you probably can't tell. By even tasting it, right, yourself, you probably can't tell. But if you put it in like a very fancy machine that scientists have that could analyze like the composition of it, you'd probably find that the composition is a little bit different. It's not exactly the same. Okay, and the difference here between substances and homogeneous mixtures is substances, their composition is exactly the same no matter where you go. There is no difference at all. It is exactly the same. Homogeneous mixtures might look the same. They might be even really, really close in terms of their composition, but they're not exactly the same. Okay, that's the difference. So we'll say similarities. So similarities, if I can spell, similarities, there we go. Similarities both have uniform composition / one phase. Differences. Substances have a definite composition. Solutions do not. Okay, that's the difference. So it's a little bit tricky, but with practice, you'll get better, okay? Think of milk, for example. Skim milk from one part of the country versus skim milk from another part. Although they're both skim milk, they both might look the same. One might have just a little bit more fat in it than another one, right? They both have little fat because they're still skim milk, but the amount of fat is going to be a little bit different just because it can't be exactly the same, right? No matter what. It's going to vary a little bit, okay? Same thing with lemonade, right? Like one lemonade might have a little bit more sugar in it than another lemonade. Same kind of deal. Substances, doesn't change, so... All right, number 6. A separation of a liquid by boiling followed by condensation is known as... So this was directly from the notes. This is known as distillation. Okay, so you separate liquids out first, you boil them, and then they turn into a gas, and then you condense them down as they go through the distillation column, and then they condense as a liquid, and they fall out the other side. Number 7, a method for separating a solid from a liquid in a heterogeneous mixture is known as... Again, this one also was directly from the notes. This is known as filtration, okay, where you separate out a solid from a liquid. You pour it typically into a filter. The liquid particles, of course, pass right through the filter. The solid particles get stuck, and then now you have the liquid over here and the solid here in the container, and you can, do whatever you want with it. So, all right. Number 8, state whether each of the following is a homogeneous or heterogeneous mixture. Okay, so table salt dissolved in water. So if you take table salt, and let's just say a little bit, so not like lots and lots of salt. But you take salt, you put it in a glass of water, it's going to dissolve. Okay, you won't be able to see it anymore. So you have two things that are mixed together. Okay, so it's a mixture. You know that the salt is still there. Okay, so we know it's a mixture. The salt is still there because if you drink the water, you're going to be able to taste the salt. So we know the salt hasn't changed into something different. Okay, it's just dissolved. And when you dissolve something, you're essentially just breaking it into really small pieces that you can't see with your eyes anymore. You can see it with a microscope, though. So this is going to be a homogeneous mixture because even though the salt looks like it's gone, it's still there. And if you look at the water, you're not going to be able to see the salt. Okay, so it's just going to look like one clear liquid. So that's homogeneous. Carbon mixed with sand. So carbon is basically just like charcoal. Okay, it's just like black little clumps of stuff. And of course, we all know what sand looks like. So if you were to mix those together, you'd be able to see the little black pieces of the charcoal. You'd be able to see the pieces of sand just with your own eyes. So this one is very clearly going to be a heterogeneous mixture because we have multiple parts that you can just easily see yourself and pick out. Okay, so that one's not too bad. Number 9, classify each of the following as a substance or a mixture. So again, substance means that it has uniform composition, it looks the same, and it has a definite composition. No matter where in the world you find it, it's always going to be exactly the same. So table sugar or sucrose is going to be a substance. And this one is kind of also a giveaway because if they give you a chemical name for something, that means it has a chemical formula, which basically means that it has a definite composition because there's a formula for it, right? Like you could say, what's the formula for sugar? You could go Google it. It's like C12H22O11 or something like that. Okay. For hot tea, there's all kinds of teas. They're all different, right? And if I made tea at my house versus I went to like a cafe and got tea or something, each one's going to be different. So this one is definitely going to be a mixture. It is not a substance because it varies it varies widely. It just depends on where you go to get it. So definitely a mixture, not a substance. All right, last question here. We'll delete this stuff if we can. Oh, can we get rid of this? Yes. All right, anyway. Air is mainly a mixture of nitrogen and oxygen with small amounts of other gases such as argon and carbon dioxide. What property could you use to separate the gases in air? All right, so we're going to insert a text box here so we can actually do some typing. But how would we separate out air, right? So air is, as you know, is colorless. You can't see it, right? It's in front of your face right now. You can't see it. You can't filter it, right? You can't take air and put it in a filter because it goes right through the holes. You can't distill it because distillation, usually it's a liquid. You'd heat it up to boil it as a gas and then condense it. Well, it's already a gas. So what if we thought about distillation, but instead of the first part where you boil it into a gas and then condense it, let's just think of the second part of that, which is just the condensing part, right? Air is already a gas. If we were to cool down a sample of air, some of the gases are going to turn into liquids sooner than the other ones are because they condense at different temperatures. So the best way to separate out the gases in air is to use condensation point. So you can lower the temperature, and it could be that the carbon dioxide comes out first. Then the nitrogen will condense next, and then the oxygen condenses third, and then the argon condenses last. And you could condense each one into a different container, and you'd have 4 containers with different, gases or different liquids in each one or whatever, okay? So the best property to use would be condensation point, okay? So we'll even describe it a bit. So you can say you can lower the temperature and each gas will turn into a liquid at different temperatures and different times. This way you can collect them in separate containers or something like that, okay? All right, so there we go. So that's probably the best way to do it. All right, and that's the last question for the notes. So hopefully that helped you. If you're confused on that, this will be a good tool for you. And as always, if you have any questions, you need any help from me, email me, reach out. I have no problem helping you, okay? All right, guys, that's it. I'm Mr. B. See you in the next one. Bye.